Hi friends. Okay, chemistry. We are going to talk about naming and drawing ionic compounds. So remember, ionic compounds are made of what? They're made of cations plus an anion, right? So you have to have, that's something with a positive charge combined with something with a negative charge, which a lot of times we talk about metals and nonmetals, but remember, they're really cations and anions. Okay, so when we have an ionic compound, we can draw them. So let's talk about how you draw the compound. So I would start with something like, I would say, can you draw for me sodium chloride? And if that's what I'm asking you to do, then you're going to look at this and you're going to say, okay, sodium, it has a symbol of Na. Chloride, I can recognize that this is chlorine because the end usually is "ide," it gets changed. And I know that that's got a symbol of Cl. Now I'm going to look at the charges. Sodium has a charge of +1 and chlorine has a negative charge. We want our charges to balance and we use the crisscross method. So 1, 1. That means to balance them, I need one sodium atom and one chlorine. And I'm going to not write in the 1 as a subscript, like one of each, but I'm not going to write those in because I kind of assume they are there. So the answer to this would be sodium chloride, NaCl. Real important you get the lowercase letters in the right spot. Okay, let's try one that's a little bit trickier than that. What if we have sodium sulfide? So if I ask you to draw for me sodium sulfide, you're going to say sodium has a symbol of Na and it's got a charge of +1. Sulfide is sulfur and its symbol is S and it's got a charge of 2, negative. So in order to get my charges to balance, because I want them to balance and equal 0, I've got 2 negatives and only 1 positive, so I'm going to need another positive in order to get this to balance. So I'm going to need 2 sodiums for every 1 sulfur to get them to balance. And so I write Na2. This little 2 goes with what's in front of it, and it's called a subscript. And then I don't need to write the 1 here because it's understood. So Na2S, sodium sulfide. Okay, now let's talk about the reverse. So what if this time I tell you to name the compound? I want you to name the compound, and it's going to go backwards. You're going to name it, and I'm going to tell you you've got CaS. So the first thing you're going to do is figure out what Ca stands for. And Ca we know stands for calcium. And S, you're going to figure out what that symbol is, and that's sulfur. Okay, so calcium, sulfur. But in all of these, we are going to take the second element and we are going to eliminate the last sound and replace it with ide. So this is going to be calcium sulfide. All right. The name has nothing to do with the amounts. So it happens to be 1-to-1, and we don't need to tell that in the name. So you just have to take the ending of the anion and replace it with ide. So calcium sulfide. Let's try another one. What if we've got, let's do sodium, let's do Na3N. Okay, so ask yourself, what does Na stand for? It stands for sodium. And what is M, or N? N is nitrogen. So I am ignoring this 3. I don't care about the 3 right now. So I am going to take the second element and I'm going to take off the last sound. So nitrogen, this is going to become nitride. So sodium nitride is the name. Sodium nitride. Let's try one more. What if I ask you about this? CaCl2. What does Ca stand for? Calcium. Actually, you know what? Before we even do that, you know what habit we just forgot to talk about? You need to ask yourself if this is ionic, because these rules only apply to ionic. And you're like, okay, I do have a metal here and a non-metal. So yes, this is ionic, so I'm going to keep going with my rule. So Ca is calcium. Cl, remember, I don't care about that 2 right now. That Cl is chlorine. Chlorine. And we're going to replace the end with ide. So this is going to be calcium chloride. And you have to write out the entire thing. All right, just one little last one. What about this guy? Al2S3. So, actually, let me give you this. Al2O3. All right, is it ionic? Aluminum is a metal, oxygen's a nonmetal, ionic, good, we can continue. So we're gonna say aluminum, because that's Al, and oxygen is going to become, we're going to take off the gen and make that, actually we're going to take off the egen, and that's going to become aluminum oxide. All right, that's all there is to it. You got it.